Good morning to one and all present here. I, Megha Gupta, welcome you all to the day two of 1 week FDP on recent tools for integration of smart systems. Today we have amongst us Dr. Rajesh Buktar, former Dean Academics, Head of Department Mechanical, Sardar Patel College of Engineering. I would like to briefly introduce you all with Dr. Rajesh Buktar. Sir has completed his B in Mechanical Engineering from Government Engineering College, Aurangabad, ME from SRTMU Nanded, and PhD in 2013 from Mumbai University in the area of perpetuating information and communication technology, that is ICT, integration in Indian auto component industries. Sir has published around 20 papers in international journals and more than 23 papers in international and national conferences. His research areas include CAD, CAM, big data analytics, machine learning, deep learning, and IoT. Sir has taken many Industry 4.0 initiatives like aligning SPEC curriculum as per Industry 4.0 requirements, development and implementation of innovative teaching learning method using augmented reality for the subject of engineering graphics. He has developed innovative question paper setting for the subject of engineering graphics using augmented reality and augmented reality enabled book for the subject of engineering graphics. Without further delay, I would like to welcome Sir and request him to take over the session on leveraging Industry 4.0 technologies for smart systems. Dr. Rajesh Buktar.
Thanks a lot, Mega Madam, for the introduction. Yeah, and I would like to thank IEEE Bombay section and the collaborative engineering colleges for giving me the opportunity to deliver this session. Hope I'm audible.
Yes, sir, you're on.
Okay, thank you. Yeah, so under IEEE Bombay section, this topic, recent tools for integration of smart system, it's really a very good initiative, I say, because right now all the industries, maybe in India or abroad, they are on the verge of implementation of Industry 4, and Industry 4 definitely requires development of smart systems. So industry people, they are looking for the development and creation of smart systems, and in turn they will be definitely banking on the intellectual smart pool workforce that will be provided by the higher and technical engineering education. So this is the right and a very opportune time that this initiative has been taken, that how these technologies, these Industry 4 technologies, or maybe the various technologies, how they can be, these tools and technologies can be integrated with each other or in isolation to develop or create smart systems. So there are a lot of applications wherein these tools and technologies, they can be leveraged. So as I said, industry will be looking for such applications, and then once you start understanding these technologies, definitely I'll tell you, sky is the limit. So there will be plethora of applications wherein you can leverage these technologies. But the proper thought processes should be triggered in that direction. So that is only going to be the inertia. So the process will be like learning and understanding the technologies and leveraging those technologies for developing some smart systems. So once I was told regarding the title of this FDP, so we had at SPC, we had this background of Industry 4, and from quite some time we had been working on Industry 4 tools and technologies, and we have developed some systems. So maybe those systems, they can be shared with you during this session, and we can understand that how the various technologies of Industry 4, they can be leveraged for development of this kind of systems. So the ground is set for everyone. So the title today is leveraging Industry 4 technologies for smart systems. So we'll try to first understand, be aware that what are the different industry 4 technologies and how they can be used for developing the smart systems. So you can see the contents, introduction to industry 4. So I think during the early discussion, you might be, or the participants might be made aware about industry 4. And so just I would like to understand whether this industry 4 introduction has been discussed with the participants, madam.
No, sir.
Okay, okay. So, so for smart systems, so everyone should understand that for developing smart systems, definitely these industry 4 technologies will be very, very useful. Therefore, one should be clear about what are these enabling technologies, how they work, and how they can be leveraged for different applications. And therefore, the second point I've covered is enabling technologies for smart systems. And then these are the all are the technologies. So therefore, we should also try to understand that what is the significance of technology integration for development of these smart systems. Then at SPC, we have developed some smart system for teaching learning, innovative teaching learning. We have developed question paper system for question paper setting and for also remote maintenance. So there are other systems also which we can discuss. So these will be the things that will be covered in today's session. So industry 4. So industry 4, it is nothing but the fourth industrial revolution. Okay. So fourth industrial revolution, it is a big bang, and uh, Germany is the country who has given birth to industry 4. The German population is aging, and they have developed these technologies basically to eliminate the expertise, maybe you can say. So if you look at the working of the system, the experts which are available are their role might be eliminated. So you can see that any new technology comes, something gets eliminated. So here, expertise in a particular uh, working process may be eliminated by making use of these technologies. So we may be calling them as smart systems, but experts are getting eliminated. So that also we need to understand. So what is there? So why the world is looking for fourth industrial revolution? Why this revolution has come with a big bang of the word, the letter 4, number 4. So you can see that so many of the participants, those who have attended the courses in different areas, they might have been little bit conversant with this industry 4, the fourth industrial revolution. They might be aware of. So those who are not aware, you can see that this is the progression of revolution: first, second, third, and fourth. So you can see in the first revolution, mechanization, water power, steam power, they had impacted that period, that era. Then mass production, assembly line, electricity, second, and in third, computer and automation. So up till now, in India, we are working on or till third industrial revolution. So the fourth industrial revolution is very important to understand. So you can see the progression of the first, second, third, and fourth industrial revolutions, how they happen. So first mechanization, second mass production, third computer and automation, and fourth is dealing with cyber physical systems. So what I understand is till third industrial revolution, people they were working more on automation. So you can see that there was a big thrust on development of automated systems. But then again, what was the pending thing or remaining thing which again that can be capitalized and the benefits can be taken if we can find that. So there were a lot of technologies, those they were emerging simultaneously, and then the fourth industrial revolution, it gives or offers the opportunity of connectivity. So The man to machine to man connectivity was missing till third industrial revolution. So fourth industrial revolution, it came with a big bang of offering this connectivity. So now man is connected with machine, machine is connected with man, and machine is connected with machine. So this was the missing thing. Maybe these technologies are filling that gap. So therefore, and this connectivity, if once it comes into the working, it is going to make difference in each and every field, each and every sector, maybe medical sector, maybe pharmaceutical sector, auto component sector, automobile, aviation sector, textile industry. So this working can bring change in all the major industries. So therefore it is called as a revolution, and therefore and it is bringing the change. Therefore this is the fourth industrial revolution. Therefore we need to understand, and this is again fourth industrial revolution. It can be what you say taken further by development of smart systems. So that is a very apt topic, as I said. So hope you understood the difference between first, second, third, and fourth industrial revolution. So you can see this. These are the various eras in which the different revolutions. So therefore, as an academician, we should be aware about this. So if you are not aware about fourth industrial revolution, so this is a good academic exercise for academicians, so that they can dig through first, second, third, and understand the difference between previous and fourth industrial revolution. So this is the same thing to the slide which I have conveyed earlier. Yeah. So these are the various enabling technologies of industry 4. And as I said, industries are on the verge of implementation of industry 4. Therefore they will be definitely looking for the talent pool and the workforce, the experts from higher and technical engineering educations. And therefore that can be done, or that can happen through development of smart systems. And therefore in that context, as industry 4 is emerging, so it becomes onus on the higher and technical engineering educations to evolve education 4 as well. So because of education 4, as I said, the workforce, the talent pool will be developed in that direction. So the enabling technologies for industry 4 or for the development of smart systems. So you can see, so once you plunge into the, if you Google industry 4, you will find various articles, and from that you will at the end come to know that these are the enabling technologies which industry 4 is talking about. And therefore our talent pool should be nurtured in this direction. Therefore our students, they must be aware of these technologies like augmented reality, virtual reality, internet of things, artificial intelligence, in that machine learning, deep learning, then big data analytics, cloud computing, 3D printing, digital simulation, robotics was the earlier uh, technology which used to work. Now cobots are being created, developed. So these are the enabling technologies for the development of smart systems. So for smart systems, there is one leaf which all participants must understand, that enabling technology is very important. So these are, so I'm through this slide I'm making you aware that these are the technologies which need to be understood for the development of smart systems. So smart systems, everybody might be aware of. So just to uh, put a slide that what are smart systems, you can see that, and in the earlier sessions also the smart system might be discussed. So smart systems incorporate functions of sensing, actuation, and control in order to describe and analyze a situation and make decisions based on the available data in a predictive or adaptive manner, thereby performing smart actions. So once something is sensed, based on that, the action should be initiated the actions. So the actuators will help to initiate those actions based on the sensing functions. So that is how the role of smart systems uh, they can play in the near coming future. And why this FDP is targeted on smart systems? Because in the coming era, in the coming near coming future, this smart system will be required, and these will be definitely part and parcel of everybody's life, and everybody is going to be witness, everybody is going to use these smart systems. So therefore one should be aware of the smart systems and the recent tools, as I said, which will help in creating this smart system. So that's a very apt title selected. So, so we'll go one by one. I have listed these 8 to 9 technologies. So we'll just try to understand what each technology means and how they can be useful or contribute towards the development of smart systems. So augmented reality is one new technology. So at SPC, we have developed some smart systems for teaching, question paper setting, using this tool of Industry 4, that is augmented reality. So we were already, or people or participant, they might be already aware about the word virtual reality. So they need to understand the difference between VR, AR, and then mixed reality, and then it goes on. So virtual reality, augmented reality, mixed reality, as of now, we should be aware of and how they can be leveraged for development of smart systems. So augmented reality. So augmented reality, once people understand augmented reality, you can see it is going to open a Pandora's box. So as I said, so if the faculties, the students, if they are going to be aware about the smart systems and the tools and technologies uh, helping to create them, I think the near coming 10 years will be really packed. There will be no time, because if you select any one of the area, every technology, area in the sense any single technology, it is going to offer you plethora of opportunities. So here, the various areas that I have just listed, which came to my mind. So augmented reality. So somebody is already working with virtual reality, then it is very easy to understand the natural progression from virtual reality to augmented reality. And you can see these various research areas or applications that are almost get open for them. So augmented reality is used in product development, in logistics, manufacturing, resource planning, non-destructive testing, assembly, maintenance, training. Training is a very uh, is a key application as far as AR is concerned, in quality control, sales, marketing, in education. So see AR in education. So being an academician, so I always tell my student that you understand any new technology, okay, so you first try to implement that technology in the area in which you are working. So I being an academician, so we at SPC understood AR technology, and we try to leverage that technology in education. Okay, so how we did that, maybe a very interesting story to share with you. So these are the 8 to 10 opportunities which augmented reality can open for the participants, the researchers who have interest in augmented reality. And then going further again, so here this slide was augmented reality working in isolation. Now this slide shows that how augmented reality technology can be integrated with other technology like IoT, and so that we can get compounded benefits. Then how augmented reality can help the enterprise-wide systems which are already in place to change the scenario. So again, I tell my students what is permanent in life, change is permanent. So these are the changing things. So Already ERP, enterprise planning, PLM, product lifecycle management, customer relationship management, manufacturing education systems, supplier relationship management, warehouse management. These are the various applications wherein this augmented reality technology can be leveraged to get benefits out of that. So at SPC, we have developed a smart system by integrating augmented reality and IoT as a solution for remote maintenance. So Internet of Things is another technology which everybody might be aware of. So this is a technology which is going to make a huge difference. So IoT plus cloud computing, it is a very deadly combination. So cloud computing is the central technology which I feel is which has helped to come up with this fourth industrial revolution. So IoT, you can see smart product development, smart logistics, smart maintenance, smart shop floor, smart warehouse, smart asset management, smart sales and marketing. So you can see every domain in which the engineer will be working, the budding engineer will be working. He is having an opportunity to integrate these technologies and develop smart systems. So now by then everybody might have got an idea what will be the smart systems and how these Industry 4 technologies can help to develop smart system in various areas. So backend integration, IoT plus ERP integration, IoT plus CR integration. So you can see again IoT helping the softwares, the enterprise-wide softwares. So these are the enterprise-wide softwares, ERP, CRM, PLM, SRM. Okay. Now, therefore, the developers, IT developers, they found an opportunity that everything is shifting to cloud because of cloud computing. So therefore, so here IoT PLM is written. So IoT plus PLM is equal to cloud PLM. So they found a new solution. So now all these enterprises, big giants industries, they will be working with cloud, and all these systems they will be available on cloud. Therefore, those will be referred as cloud PLM, cloud CRM, cloud ERP, cloud SRM. So majority businesses. So there was a slide wherein they have written that majority businesses they will be shifted to cloud. Only they will be leaving few businesses. So there can be in shortly there can be a mandate that everything that can be used that will be done through cloud, because there are a lot of advantages of doing everything on cloud. So you people might be aware that the benefits of cloud computing you might be aware of. So a lot of resources, infrastructure, processing power will directly get from cloud instead of having the same system, infrastructure, resources at your end. So they'll be centrally managed. This is another very, very interesting application. Have you heard of digital twin? So again, it is a smart system. So you can see here, so digital twin at the right hand side here, and is written IoT platform. So you should also be aware about IoT platform and IIoT platform, industrial. So industrial Internet of Things and IoT Internet of Things. So IoT that will be using some sensors and some microcontroller. Here the top vendors, the leading vendors like PTC, Azure, Amazon, Amazon for say your social networking, but Azure, Oracle, PTC, these are the leading vendors of development of industrial IoT platform, because the data that is getting generated is very huge. So humongous amount of data is getting generated. So your smart systems talks about collection of this data, analysis of this data, visualization of this data, and developing actionable insights which we were not able to through this data. Understand? So this is the fourth industrial revolution or the development of smart systems. They are going to help the academicians, industrialists to gather the data, analyze the data, and develop actionable insights or the trends and patterns which are hidden in the data. So this is what actually the whole smart systems they are going to talk about. So digital twin is another application. So digital twin basically it caters to the development of product development, and since all these technology. So as I said that I always tell my students if I understand any new technology, then you should first think that how that technology can be utilized in my domain. So everybody was utilizing. So product development was another area. So the product development people, when all these technologies were discussed, understood, then they thought that how can we utilize this technology in developing a product. So in a product development, we have seen that we develop a product using a software like Pro Engineering, CATIA, Unigraphics, SolidWorks. Of course, you might have heard the name of all these softwares. And then you create a rapid prototype of that. So you also might be aware about that. So on rapid prototype, you do the testing and everything. So what is the gap in this process? So you need to analyze your existing working styles in this fashion, and that is how it is going to give birth, at least initially, an idea that this is the gap. So if you can use these technologies, this gap can be catered in this fashion. So digital twin here, I'd like to showcase.
Where the digital reality of product design,
Yeah, the video is visible, I suppose.
Yes, sir. Yes, sir.
put in summary, this new reality requires a new technology platform and new applications to solve new problems, and it requires enhancements to existing business systems to deliver more value than ever before. Operation shows the most interesting and important implications of this new
So you can see
reality.
this is the
We start with the
digital
reality
model,
of the 3D CAD model. The
CAD
Santa
model.
Cruz V10 downhill race bike is completely designed and engineered in PTC Creo. However, the bike wasn't designed to be smart and connected. A
So this
reality
is
for many products on
designed
the
in
market today.
PTC
So we
Creo,
instrumented it
and
with
this is the
sensors
actual
to
bike.
measure and monitor the key characteristics that will help us understand the performance, as well as a Raspberry
you can
Pi
see
computer for connectivity. The result is a product that combines the digital
this
and physical into this new
bicycle.
reality.
It is
As the
installed
rider
with
interacts with the bike, the ThingWorks
sensors.
platform connects and displays wheel speed,
So you have
compression
now
on the
seen this
suspension
before,
mechanisms, and steering
that
angle
on the
measured
3D
by the
model,
angle of rotation on the handlebars.
the
By combining
sensor
the power of
readings
CAD and PLM with the ThingWorks IoT
are
platform,
overlaid.
we're able to merge real-world physical interactions
So you
into
can
the
see
digital
the
world of
physical
PTC
interaction is
Creo,
happening with the digital
creating
model.
the digital twin.
This
The
was
digital twin is a representation of this particular physical bike. As the bike moves in physical reality, the digital twin updates in real time.
so digital
And
twin
PTC
updates
Creo
the real-time
recognizes data
readings.
from the sensors and performs basic physical analysis for deeper insight into the product's behavior. This contextualized feedback provides a new level of detail to remotely understand real-world product usage and what customers value most. In the ThingWorks dashboard, we have also added some simple analytics, including a slip skid indicator that indicates a difference in RPMs between the front and rear wheels, as well as other force-related analysis. Analytics such as this translate the voice of the product into actionable, real-time product insight. Complete and remote understanding of the product is extremely valuable, but the
You can
concepts
see
shown
here,
thus far also provide the foundation to
scanning
make augmented
the
reality
code.
part of this new reality. The augmented reality application we've developed for this tablet is linked to this exact bicycle by scanning the serial number, and the AR tag provides the 3D reference
So you
coordinate
can see
system.
the
The
readings are
application
getting
then
overlaid.
projects or augments the dashboard onto that bicycle, containing much of the same data we've seen throughout this demo. real RPMs, engineering analytics from CAD in the form of force vectors, and a simple slip skid analytics indicator. The practical applications for this new technology are far-reaching and deliver a new reality powered by PTC.
Were you able to understand that digital twin video?
Yes, sir.
So your title is smart systems, and smart systems, it always it is incorporating the IoT feature, the readings features. So you can see that a new smart system has been developed. So smart system is the generic tag, but the real name of the system is digital twin. So this was not possible earlier, that your 3D model will have the live streaming readings, live streaming data overlaid on a 3D model. So this was not possible 5 years down the line. But just because of the emergence of this industry 4 and its enabling technologies, this is being possible. So you can see, once you get the data, then you can play with the data, you can analyze the data. That is what the real outcome. So you can see here, this is another slide. So smart systems, they are nothing but the combination of OT and IT technologies, operating technologies and information technologies. So you can see on the left side, this OT and IT technology are combined to form digital twin. And once digital twin is formed, you can develop manufacturing apps, you can store the data, you can visualize the data, you can integrate various services. Augmented reality can be integrated. You can do the data analytics of the same using various machine learning and deep learning algorithms. So this is one of the interesting smart systems. And once you get the data, you can see that you can understand this analytic value escalator. So you can do descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So that is the outcome of development of all these smart systems. So once the digital twin of a particular product starts acquiring the data, okay, so that data will help you develop the insights that what happened in the past, what is going to happen in the future. All that analytics can be done using that data. So similarly, digital twin, one of the beautiful application of digital twin is smart cities. So smart cities, you can see all these enabling technologies of industry 4, they can be leveraged for creation of a smart city. So smart city is nothing but again a smart system. So you can see already AR, VR is being used, artificial intelligence, that is machine learning, deep learning, big data analytics, visualization, IoT, cloud, 5G, everything. So we can see on the right hand side it is OT, and on the left hand side it is IT. So it is nothing but a combination of OT and IT for development of smart systems. So this slide is a classic example to exemplify that concept. So with smart city development, cities aim to optimize overall performance of the city, its infrastructure, process and services, and also improve socio-economic well-being. So people love technology, so they would like to work with new technology, and therefore newer technologies are being evolved, which will help to optimize the overall performance of a particular application. So we discussed about augmented reality, we discussed about IoT, digital twin, artificial intelligence. So this slide everybody might be aware of. So artificial intelligence is the main umbrella. Below that is machine learning. So machine learning is a subset of artificial intelligence, and in turn, deep learning is subset of machine learning. So you people might be already aware of what is the difference between artificial intelligence, machine learning, deep learning. Okay, so no need to tell to you. So machine learning, a lot of applications of machine learning. You have to again visit machine learning, and you should also need to understand that why we are forced to revisit these technologies. So machine learning was already in existence, but now you can see there is increase in data generation will help us to solve complex problems by uncovering patterns and trends in the data, and that will help the enterprises and higher and technical engineering educations in improved and enhanced decision making. So this need not to be told to you, that is already understood by you. So machine learning, again, it is going to open a lot of research areas. There is one slide which is giving you that information. Deep learning, new algorithms, convolutional neural network, generative adversarial network, that is GAN, autoencoder and decoders, recurrent neural network. So if you study and understand these algorithms using Python programming, there are a lot of applications or smart systems that can be developed. So the message through this slide is deep learning, it constitutes these different kinds of algorithms, and these algorithms, they are being already leveraged for development of different systems. That is the message. So you can see that one beautiful classic example of these algorithms getting leveraged in mechanical engineering. See, since I being having a background of mechanical engineering, yeah, am I audible? No.
Yes, yes, sir.
Yeah, thank you. So on the left hand side, you can see this is the 3D model created in the software. Okay, and then generate, explore, and this is the result. So this is the innovative design process. So generative design, again, it is a smart system developed for generating newer designs which are not understood or which a human being is not capable to think about. So to make it more simpler, I'll give you an example like if we develop a design, say so knuckle joint, quarter joint, these are the examples you are aware of, or you take example of any product. Okay. So what you can do, a human being, he will try to think about one more new design. Okay. So at most he will think about two designs or three designs. But then once this process is understood by the algorithms, softwares, then it will generate thousands of solutions, lakhs of solutions for one particular design which human being is not capable of thinking. So in the earlier slide where I've made you aware about deep learning algorithms, so using those algorithms, you can see that how many newer designs are being offered. So these are the generated designs through software using these technologies. So you can see one classic example of digital twin, that where we can develop smart system for developing product. So product development domain has utilized these enabling technologies, how they can collect, analyze the data and develop actionable insights. Here also you can see how these technologies, they are helping. So that was in product development, this is in the design, how this design can be optimized. Deep learning algorithms. So not only deep learning algorithms are used, genetic algorithms along with topology optimization algorithms, they are being used to develop these designs. So you can see input is given. This is the black box, the magic box, which is now available in the form of a software. So you also need to demystify this black box. What is hidden in this black box? So machine learning, deep learning algorithms, genetic algorithms, and topology optimization algorithms, they can be forming the part and parcel of this black box. So design is given to this black box. Automatically, this black box will generate these designs on cloud. You can see how cloud computing is helping to generate these designs faster. And out of this design, one best design will be selected, and that design will be manufactured. So you can see the result is one. So out of these available options, one best option as per our needs and requirements will be selected, and that will be manufactured. So at SPC, using CNN autoencoder, decoder, and topology optimization algorithms, we have developed these generative designs for a bicycle frame. So this is our original work, which has been conducted at SPC. So you can see that number of designs for bicycle frame we were successful in developing. So this is in the domain of mechanical engineering. The earlier example we saw, but now you can see this is a domain for civil engineering. So as I said, once the participant or the student or the talent pool or the budding engineers, they become aware of these technologies, not only in their domain, they can use these technologies, but there will be many other domains which will be open to get employed. Therefore, this smart systems also gives us a message to understand the domain knowledge of other branches also. So like the computer engineers, the electronics engineers, the IT students, they also need to understand a little bit mechanical engineering, civil engineering, electrical engineering, because the smart systems which they will be developing will majority they will for these domains. So as I said, IT tools, this domain knowledge is also going to help you. So therefore, the evolvement of education for also needs to think in this direction. The domain knowledge will also need to be considered in computer electronics IT domain as well, because these systems we were able to develop or by our mechanical engineering students. So they had to travel an extra mile to understand these electronics IT combination technologies. So they have also traveled an extra mile, and maybe that is the need of today. Big data analytics, as I said, again, this is a new enabling technology. So if people or the students, engineers, or the participants, they are already aware about the databases, then definitely this big data analytics, they'll be able to understand. So as you all are aware that humongous amount of data is getting generated through social media, Instagram, WhatsApp, Facebook, Twitter. So all that data needs to be analyzed. And you can see on Facebook, on Instagram, YouTube, Netflix, you can see these recommendation systems developed using big data analytics. Therefore, the social media fraternity, how they are keeping us glued to mobile through development of these systems, recommendation engines. So whatever you like, you post your opinion. Based on that opinion, the data will be analyzed, and similar sort of stuff will be presented to you. That is happening. So everybody might be aware of that. So just big data analytics came for discussion in our slide. So I'm giving you that information. So you want to understand big data analytics. Yes, am I audible now?
Yes.
Yeah. Sorry for the disturbance. Yeah, okay. So if you want to be aware about big data analytics, these are the This is a journey which one needs to travel, understanding various databases, relational database, object oriented, and NoSQL databases. So NoSQL databases are the one. So in this new generation, new suite of softwares are developed by the. So we need to understand how they work and develop smart systems accordingly. So NoSQL databases, you need to understand document database, key value pair database, graph database, columnar database. So again, I'm happy to inform you that in SPC, in the last semester only, we were able to conduct an open elective on big data analytics for the students of mechanical, electrical, and civil engineering. So all the students of three branches have enrolled for this, and in the mini project, they have developed some small systems using the big data analytics technologies. So again, you already might be aware about what are the advantages of big data analytics. So as I said, these technologies they are coming. We should aware about the elimination of expertise. So once the data, you get humongous amount of data, and the budding engineers they get trained in analyzing that data. So so human resource you can say is one area where HR person is appointed. So if you understand big data technologies and you can use the tools for big data technologies, then by doing HR analytics, the HR analytics person can be eliminated from the enterprise. Yeah, of course, definitely he will be put to some other use. But then, as I said, how this technology will be penetrating the different domains, how they are going to make impact on various domains. So that also is another dimension which one needs to understand through this course. So yeah, so at SPC, we are working on document databases, key value, columnar. But as of now, to share with you, this is the graph databases. So again, I'm happy to share that at SPC, we have developed this application using Neo4j software, which is exclusively used for graph database. So our students at SPC, they have used this software and they have developed this network of graphs for some welding system. This is done using Neo4j. But again, there will be few people who will be working in IoT, few will be working in AR, VR, big data. So if you get a flair of all these technologies, then you can also think about integrations. That is another again component advantage. So that will again your another 5 to 10 years will be again. पहले तो मैंने बोला कि 10 years from down the line here, they are going to be very interesting. And how to break our monotony in the job using technologies. So you can see here, this is graph developed using Neo4j. And along with the graph, Neo4j is helping to overlay the contextual information. So which will help to track and understand to help enhance decision making. You can see that this one. So that was Neo4j software for big data. This is Unity software of augmented reality. You see how beautiful and deadly combination maybe. So this step we have taken at SPCE by understanding the fact that the big data is going to be humongous, huge amount in size, petabytes, zettabytes. So there will also be a problem in visualizing the data. So even though R, Tableau, Matplotlib, Seaborn, these libraries are there, softwares are there, Tableau, R, but they will be visualizing the data still on a 2D screen. And in augmented reality, I am yet to show you the demonstration of augmented reality smart system. That if that data is brought in 3D, so you can see the 3D power of visualization, the third dimension will be leveraged with that data, and it will be so very useful to visualize that data in 3D. And that is in the software, and Microsoft, they have come up with hardware, Microsoft HoloLens. So using that HoloLens, you can actually feel the data, you can touch the data, you can manipulate the data. And by manipulating the data, you'll be able to visualize it properly and take enhanced decision. Because in 2D screens, what is going to happen? Like a hairball, this data will be cluttered and you will not be able to visualize. Data is there, but you are not able to visualize. That is going to be the problem. So through literature survey, we understood that this is a problem. So we tried to give solution by bringing that data in augmented reality. So Unity is the software in which we have brought this data, and then again we can make use of the advantages offered of 3D as far as visualization is concerned. So this data again will be a 3D model, just like the 3D model of a clamp, knuckle joint, quarter joint. This will be the 3D model of the data. Have you ever imagined this? So this is again opening a new opportunity for the budding engineers to understand, travel an extra mile, to understand 3D visualization softwares like Unity, augmented reality, or Viewforest Studio from PTC. Gain expertise in that and bring that data in 3D and visualize the data as per the needs and requirements. So this is one of the important milestone we have achieved at SPC, bringing this data into augmented reality. And not only the data we have brought, you can see the contextual data is also being overlaid. You can see what each node, so this is almost like a edge node data. What is the name of each node? Then you can click and go on drilling the data, and you can understand how that one node is connected with other nodes and how the relationship is established. And by making use of or by understanding that relationship, how we can develop a new business and revenue model. So basically, the tools, recent tools used for developing smart systems. Okay. So the tools you can see, you can witness that the tools, recent tools of Industry 4, they are being utilized for developing smart systems, for data visualization. And what is there after that? You analyze the data, you develop actionable insights, and thereafter you go on to build new business and revenue models, which are not existing in the market right now. So every industry, maybe pharmaceutical industry, textile industry, automobile industry, many industries, there is a huge scope for development of such new business and revenue models. So you can see that this is how you can manipulate the data in 3D visualization software Unity. So you can manipulate nodes, and then the nodes, the color you can change, the shape of the node you can change, triangle, rectangle for particular node, and the lines are the edges which are connecting one node with the another node. You can make it dotted, you can hide them to visualize the data. So that is what is the power of 3D visualization in 3D software, SCAD models. So you can go manipulating this whole data as per your needs and requirements and understand what that data is to tell you. So this is where the whole expertise is going to lie. So these are the tools which are going to help you and the data. So you can see here the same. So we have taken a sample data to illustrate that how big data can also be analyzed in Unity software. So you can see, you can change. So the nodes are there. We can change the color of the nodes, green, black, red, blue, yellow. So a particular node will represent a particular customer segment. Then every node is connected. One node is connected with another node with the help of edges. That is lines. So the color of the lines can be changed. The nodes can be this. The edges can be made dotted. They can be hidden. As we hide this in our CAD model, so this data is now converted into a 3D model. So using the Microsoft HoloLens, you can touch this data and you can manipulate data. So visualization of the data is very important, while or it is a very important step in big data visualization. So as I said, if it is a hairball, it will be very difficult to imagine that data. So Unity can be used as a tool for understanding that data. So this is some just to tell that if we switch on to understand these technologies for smart systems, the huge salary offers they are beating. So this is one slide which I thought I can share with ecosystem which everybody is aware of. So one has to understand HDFS, Yarn, MapReduce, HBase, HCatalog, Uzi, Scoop, Zoo Coordinator, Flume. So that is what I said. So big data drill was in isolation, so it will be integrated with AR, new for data visualization. Softwares. So now Hadoop ecosystem for you people now it is getting older now. It's replaced by PySpark and all the new generation of softwares. So our students at SPC they have used PySpark, they have used MapReduce for analyzing the data. So big data analytics again it is going to open up huge opportunities in various domains. You can see here cobots, collaborative robots. So this is another piece wherein new cobots are being emerged and they will be working with people, not in isolation. So therefore, they are called as collaborative robots. So this is another piece of enabling technologies we can understand. 3D printing. So you might have seen that in generative design, as I said, new designs will be generated, optimized designs will be generated. So the new designs which will be offered or developed by the software, so the existing conventional manufacturing technologies may not be in a position to develop those designs. So therefore, 3D printing, which was missing this, so once again the limelight is shifted on 3D printing process, and you have seen in the this Bharat Sarkar Yojana of the startups, many engineers, budding engineers, or many engineering colleges, they have gone after this 3D printing, and they have developed various materials for 3D printing. So you can see it's a lot of different materials are available apart from plastics. So that is one of the important utility of 3D printing. But now because of generative design existence, the limelight is again shifted back to 3D printing. So there are green days in 3D printing, simulation, everybody aware of cloud computing, software as a service, platform as a service, infrastructure as a service. These are the availability with cloud computing, blockchain technology, the digital ledger. You can explore this technology as well. So this technology again it is working in tandem with another technologies. So for security purpose, so wherever the security is required, you can see cross-check the combination whether blockchain can be integrated with the technology. So all these, so this is significance of industry 4, that is the smart systems. Okay, because we need to understand these smart systems, develop these smart systems because the near future, as I talked earlier in my earlier presentation, that smart products are going to be part and parcel in the near coming future. Smart cars, vehicles. So basically, the smart product is the word which is very appealing. But then at the bottom line, this is connectivity. So smart and connected products, smart and connected cars. Okay, smart cities, smart homes, smart farming, smart supply chain. So you can see this how IoT, augmented reality, VR, big data analytics, how these companies, these technologies, they are going to play pivotal role in development of all these smart systems. So smart city is one of the important leaf you can take from this. So wherein our Prime Minister has announced for the development of 100 smart cities. Okay, so they will be requiring huge experts in this direction if smart cities can go into roll on. Really, they will be developed. So you can see the expertise development in these technologies can fetch you employability. So augmented reality is one technology which we initially tackled with. So augmented reality is nothing but the overlay of the digital content into the real world. So there is a code like a Paytm code. So using your smart mobiles through camera, you can scan that code and the digital content, the 3D model or the digital content that will be overlaid on your smart mobile. So there is a good opportunity this technology is offering to converge real or to say your real and digital world can coexist together. That is the opportunity this technology is offering. So digital content can be 2D tags, 3D model, graphics, animation, and so on. So we created a 3D model in software, then we imported that this 3D model to say augmented reality software, where we attach that 3D model with a 2D code, and that code is printed. And once so you can scan that code using your smart mobile through an app, and then you can view your AR content on that. So the theory around that is the computer vision algorithms are useful in augmented reality, uh, all this stuff. And upon recognition, we could display relevant information floating on the screen. So Vuforia software from PTC. So PTC Parametric Technology Corporation is the leading technology for providing these smart systems. So I thought you should be aware about this leading vendor. Therefore, this slide is put up. Unity is another technology software. This student version is freely available. Vuforia Studio from PTC. I think now a 15 days free version is available. Software Developer Kit SDK is again a free open source software. Hardware is used HMD, smartphone, tablet, handheld device, Microsoft HoloLens, smart glasses. So soon, this Microsoft HoloLens smart glasses will be part and parcel. Maybe in the malls, you'll be witnessing this. So this is just a difference between VR, AR, and MR technology. So like this, VR was a virtual reality. It requires the 3D model which is created, that should be there. So 100% by volume that 3D model should be available in virtual reality software. But in augmented reality, even the 30% of the actual model is sufficient. So that is the advantage with AR. And once we view this AR using the Microsoft HoloLens, it becomes a mixed reality, so that the user will be able to touch the data, touch the solid model using Microsoft HoloLens. So this is one, it's a neutral slide, which I thought that it should be part and parcel of any presentation which I'm delivering. Technology integration, because right now we have seen that even though recent tools and smart systems we are talking, but at the underneath lies the technology. So why we should give the importance to technology, that we should understand, and how industries are looking towards this. Technology is very important because technology can act as a differentiator, force multiplier, resource multiplier. That is very important. So once you become aware of a particular technology, then like at SPC, we became aware of AR, and then we went on to develop some smart system for teaching, learning, question paper setting, for remote maintenance. So it helps you to go up in value chain. So suppose any college, if they understand this technology, so definitely it will create a difference. Their budding engineers will be different from the other engineering colleges. So technology can act as a differentiator. So similarly, in industries also, if a company they integrates a technology first, they will be the early bird advantage takers. So that company will be differentiated with other company, and that is how they will go up in value chain. They will go above other companies at least for 5 years, remain competitive in market for 5 years, until other technologies understand the technology which the earlier company has integrated. The earlier company would have already escalated to another technology, and they would create a gap of another 5 years. So this is how you can go up in value chain. You can get early bird advantage. So that can be the unique selling point of the that particular institute, that particular industry. And to integrate a technology, these industries, they are having a technology adoption department, technology acquisition department. So in which there are technology trackers, and these technology trackers, they will be tracking various new coming technologies, old technologies, and they have developed this department, technology adoption department. Industry people, they are having this department, and they are integrating the technologies, newer technologies, 10 years before, for the products of the. So these industries, they have set up a technology adoption department in their industries, and they'll be integrating these technologies 10 years before, for the products of the, for the products of tomorrow, which will be coming 10 years after. So that culture we need to understand, and I think that is where there is always a industry institute gap. But then this being a very opportune time for higher and technical engineering education institutes to close this gap by becoming the masters of this industry for technologies and going up in value chain as compared to the industries, because these technologies are interdisciplinary technologies, and that is where understanding these technologies, these industry people, they have stuck up. And since it is a very new thing, this is a very golden time for the academicians to understand these technologies first as compared to the industry people, and then help the industries to implement this and develop these smart systems. And industries are also now will be open to take help of the engineering institutions, and that is what is happening in abroad. So that is what I would like to share this slide on technology integration. This because technology can act as a differentiator. Technology adoption department is important. You need to be technology tracker, and the main parameter of technology is technology disruption. Because suppose there is a person who has developed his business in television. So he has developed his business in east, west, north, south, all the four directions of the country, and then he is working with the old television sets with CRT. But thereafter, you saw the thin monitors, the TFT monitors, they took place in the market, and the space consumed by this thin monitor was less. They were portable, and definitely that was the first choice of the customer. And so, if that person who has set up his business in four directions, if he is not a technology tracker, his business will be abandoned. Therefore, we need to be technology trackers, and that is where the problem is with the higher and technical engineering institutions as well. So we need to be aware about technology disruption, because so technology can disrupt the earlier styles of working, earlier methods of working, earlier ways of working. That we need to understand. And today, by now, we should have been ready for the classrooms which were equipped with Industry 4 technologies, for the talent pool who are used to work with smart mobiles. So that could have been a deadly combination. So that is where we need to try to understand these technologies and develop such type of smart systems in the institutes as well. So once our budding engineers, they become aware of these technologies, they will be able to develop new startup models. Okay, so you can see, so we develop this for say engineering graphics. So I'll just keep this. So this is a 3D model engineering graphics. This is how you acquire the 3D model in augmented reality software. This is through our for our paper. This is already published. You can see how the student is accessing the augmented reality model using smart mobile. You can see here. You can see the green thing mark. This is the code. This is the code. Green thing mark. Okay, so this is how we develop for various, and then we develop for many models, and we created a book out of that. Okay, So here again I would like to show how it actually works. You can see here. This is the hexagonal code. So you scan that code through mobile. The 3D model will be visible on your smart mobile. There and there itself. So whether you are in classroom, your lab, or you are at home, or anywhere at your native place. You can see how this augmented reality model it appears by scanning the code, and then student can turn this model, rotate this model, scale this model. Once again, I'll play this for you. So you can see the 2D views are given. Student will be uh, not able to understand these 2D views. So for that, a 3D model will be required. And you can see using your mobile, you can scan that hexagon code. So you can see that. Then you can see here.
See, these are our lathe machines, and this is our shaper machine.
So you can see here. This is the workshop of SPC. This is the shaper machine.
We cannot see it.
You can see that hexagonal code is pasted on the rocker mechanism, which is housed inside the shaper machine. So you can scan this thing mark through your smart mobile, and you can show so that rocker mechanism will appear on your smart mobile, and you can show the student that how the shaper mechanism works in shaper machine. You can see, yes, like this. So this mechanism is housed inside. So whenever the supervisor is there, he will tell the students that there is a mechanism which is housed inside, and this mechanism works like this, and because of which these such movements are there. So now using augmented reality technology, we can see that how that mechanism can be brought outside. So this is for drilling machine. So you can develop all these smart systems in your education institute as well. You can see upon scanning, the augmented reality experience will appear for drilling machine, AR experience. And so this was a small work we have done. So the budding engineers can take this to a different level, because a lot of new facilities are provided in the software. You can see how the mechanism is moving, so that can, so students in the absence of the supervisor also, they can scan this, they can understand the working of this machine. That is the benefit. You can see here. So lot many facilities can be provided. So similarly, we did it for milling machine, drilling machine, lathe machine, so on and so forth. See in the classroom how the students are visualizing this AR experience. The overlay of 3D models in the real world. So you can see how the medical sector is utilizing this. So that was for teaching learning. Then for question paper setting, you can see on the left hand side, this figure is there. We have to find or check answers out of this. So how, for this type of questions, how AR can be utilized, you can see. So this left hand part, it got substituted by a thing mark. And see how the students scan that thing mark, try to answer the questions. And then we took a survey feedback. And then we understood that the students also need to be shown this in an exploded view. So we provided the facility of exploded view, how every component, every assembly is made of different components. So students will be able to understand and draw the orthographic views, sectional views. We provided sectional view facility accordingly. So building this next generation workflows through creation of smart system is very important, which is the app title, and these are the software skills, which I thought this is created by me only. These are the various technologies, what are the soft skill required, and what are the employment opportunities, what is expertise required. So this can be of use. So I thought of sharing this slide as well. These are the acknowledgement for the videos. Yeah. Thank you.
Thank you so much, sir, for such a wonderful presentation. Participants, if you have any questions, please either raise your hands or please put your question here in the chat box. Or you can directly unmute and ask your question if you have any. Okay, sir, I would request you to please share your mobile number if possible here in the chat box, or your at least the email ID, so that if participants will be having any questions later on, they can contact you. And since there are no questions, so I would like to
I have one question.
Yeah, ma'am, please.
Yeah, sir, your question paper use of the tool was very interesting. I just
Yes.
wanted to know, like, was it only for the COVID time that it was adopted, or it's like when we are conducting it offline, because we won't be able to give them the allow them for the use of mobiles in the classroom. So how
So yeah. So that is definitely a doubt that will be coming to the professor's mind. So for that, like the things are changing, shifting, paradigm shift is there. So therefore, we need to provide separate iPads, okay, which will only be equipped with these things, nothing in that.
Okay.
So again, so the examination department is having a lot of budget also, as they collect the fees, examination fees. So they can utilize all these things for deployment of such type of hardwares, and thereby you can make the exam interesting, joyful, and joyful learning, joyful question paper writing as well.
Yeah, very nice, sir. Very innovative, sir.
Yeah, thank you, ma'am.
So thank you very much, sir, for sharing your experience and knowledge with us. This is really very helpful for all of us, as this is the need of the hour. NEP 2020, NBA NAC, everyone is talking in this particular direction. So this is very helpful for all the faculty members here to implement diverse areas in their own institutes, especially for the mechanical engineering faculty members. So thanks a lot, sir. Thank you very much.
Thank you, madam, for giving me the opportunity to share my views here. Thank you once again.